You're listening to the N2K Space Network.
The IT world used to be simpler. You only had to secure and manage environments that you controlled. Then came new technologies and new ways to work. Now, employees, apps, and networks are everywhere. This means poor visibility, security gaps, and added risk. That's why Cloudflare created the first-ever connectivity cloud. Visit cloudflare.com to protect your business everywhere you do business.
Current events and geopolitics being what they are, national security, no matter what nation you belong to, is getting a lot of financial focus. We're seeing that in private investment firms around the world who are continuing to invest serious cash in companies, especially in aerospace, whose missions align closely with national security interests. So with today's news, let's follow the money being invested in the aerospace industry.
T-minus 20 seconds to LOS speed risk. Go for deploy. Roger roll.
Today is July 11th, 2024. I'm Maria Varmazes, and this is T-minus. VCs, AE Industrial Partners, and Alpine Space Ventures closed big funding rounds for aerospace investments. Crossbow raises $70 million to develop solid motor programs and hypersonic vehicles. And our guest today is Jaydee Dyess, Director of Test Operations at Agile Space Industries. Let's take a look at our intel briefing for today. And today we're learning that private equity firm AE Industrial Partners is closing its third private equity round, with $1.28 billion in total financing going to 5 organizations and 3 add-on investments across the national security, aerospace, and industrial services industries. Of the 5 organizations who have already begun receiving investments from this fund, York Space Systems and Firefly Aerospace are the 2 aerospace firms receiving investment. AEI says their investments target companies like Firefly and York Space because of their strong growth potential in order to scale up critical national security supply chains and suppliers to meet ongoing and increased demand. And it's not just AE Industrial Partners making headlines for raising capital for aerospace. Munich-based Alpine Space Ventures have closed a $184 million funding round, making them the largest first-time VC fund dedicated to space globally. The VC's limited partners include major institutions like the European Investment Fund, the NATO Innovation Fund, and others. Alpine says that the new capital is earmarked for no more than 10 to 15 investments, 5 of which have already been made, with check sizes up to $5.4 million. Around 70% of the fund is earmarked for European companies, but the firm says it is interested in investing on both sides of the Atlantic. Alpine Space Ventures' portfolio already includes U.S.-based satellite manufacturer K2 Space and German satellite builder Reflex Aerospace. And staying with funding news, Crossbow Systems has raised over $70 million in a Series B funding round. The company says it will use the funding to accelerate the development of its hypersonic-capable vehicles and its solid rocket motor programs. Crossbow also plans to complete its Luling, Texas Gigafactory campus and expand its engineering and R&D facilities across New Mexico. Crossbow's CEO and founder Jason Hundley says this expansion addresses both critical industrial base and defense needs in the United States. Booz Allen Ventures has made an undisclosed investment in an early-stage commercial space technology company called Quindar. Quindar focuses on automating and democratizing satellite operations. Booz Allen says this investment is aligned with the firm's velocity, leadership, and technology business strategy and highlights the urgency of integrating mission-critical technologies across the space domain to increase awareness, security, automation, and data collection for decision advantage on a global scale. Booz Allen's $100 million corporate venture capital arm has made strategic investments in early-stage companies developing dual-use commercial technologies. This is the second space-focused investment made by Booz Allen Ventures since its inception in 2022. D-Orbit is claiming its presence in America by opening a subsidiary, D-Orbit USA. The Italian-based space logistics company has announced the joint venture with U.S. space veterans Mike Cassidy, Mark Krebs, Miles Gazik, Danny Field, and David Harrower. D-Orbit USA will focus on satellite bus design, manufacturing, and sales. D-Orbit says it chose to create this joint venture in the United States in response to forecasts for the space industry, which suggest a significant growth from an estimated $546 billion at the end of 2023 to over $1 trillion by 2030. Autonomous vehicle company Gainz has received a Space Florida Israel Innovation Grant to support the development and implementation of a leading-edge system architecture leveraging non-geostationary satellite technology. This grant will fund the development of Gainz autonomous vehicle communication by establishing a reliable and redundant connection with remote monitor and control centers. NASA's Deputy Administrator Pam Melroy has embarked on a week-long visit to Japan and the Republic of Korea to underscore the critical role of international cooperation in advancing space exploration and technology development. Melroy will engage with ministers and other senior government officials in both countries, including leaders from JAXA and CASA, to strengthen partnerships and highlight civil space cooperation. And that concludes our Intel briefing for today. Check out the links in the show notes for further information on any of the stories that we've mentioned in the show. We have also added an announcement for the next launch window for Rocket Lab's 51st Electron launch, and a story on an Indian firm building space habitats. Those stories and more can be found on our website, space.n2k.com. Hey, T-Minus crew, if your business is looking to grow your voice in the industry, expand the reach of your thought leadership, or recruit talent, T-Minus can help. We'd like to hear from you. Send us an email at space@n2k.com or send us a note through our website so we can connect about building a program to meet your goals.
This September 18th and 19th in Denver, a tight community of leading experts is gathering to tackle the toughest cybersecurity challenges we face. It's happening at MWise, the unique conference built by practitioners for practitioners. Brought to you by Mandiant, now part of Google Cloud, MWise features one-to-one access with industry experts and fresh insights into the topics that matter most, right now, to frontline practitioners. Register early and save at mwise.io/cyberwire. That's mwise.io/cyberwire.
Our guest today is Jaydee Dyess, Director of Test Operations at Agile Space Industries. We talked about the importance of testing, and I asked what facilities Agile Space offers.
We have two test stands. One of them's older, Sunshine is what it's called. They're all named after mountains, so we have Sunshine and Animus. And their first one was built to be torn down on trailers, so it's all these custom modded trailers that you could tear down, take to Mojave, set back up, and test. But we don't do that anymore. That's when we used to test for external only. Once we started doing our internal design development, we test our own stuff. And so it all stays here in Durango, which is awesome. We're at 6,000 feet here, so our altitude systems get some efficiency bump from that, from being higher altitude, which is great. But that's not the reason they did it. It's mostly because it's beautiful here, but we just get the added benefit of having the altitude system. But yeah, maintaining those two stands is the big part of the job, and kind of getting through the testing campaigns. I think right now we're testing 4 different kinds of thrusters, and we're kind of alternating them on the 2 different stands. And they're all hypergolic in some way. So they either use like a hydrazine or a monomethylhydrazine. and then usually mix that with an oxidizer like a MON3 or a nitrogen tetroxide, effectively like an oxidizer or oxidation level of a nitrogen. And then we run them through the test stands, which are motive gas systems, which are just really big rockets. They're big cold gas thrusters that help simulate the vacuum of space. So, we test all these things in a vacuum to some extent because the heating profile is a lot different. When you're in space, you can't, there's no convection. There's no way for the heat to get out except for through radiation. And if people are testing that stuff atmospherically, which you do, you don't really get a good idea of how much heat soak back you might get into the system or the vacuum start. So we use, our test stands are set up like a 2-stage motive gas system. So we have massive nitrogen storage. We have a 6,000 gallon liquid tank and an 11,000 gallon liquid tank. And then we pump that through a vaporizer setup. So it takes the liquid gas, our liquid nitrogen, turns it into LN2 to liquid nitrogen. And then we pump up tube trailers and ground storage to 2,500 PSI, pretty high. And then we just let it rip. The whole thing just blows down through a regulation system that, fires through our altitude system, and it acts like a big Venturi. So it sucks all the out of the air out, and the thruster that we're testing can fire into a cell and have all the nitrogen actually take all of the gas from the exhaust out of the thruster and still maintain a vacuum. And usually those are 0.1 psi. So in the vacuum, so a few 100,000 feet, which is pretty good. NASA and some of the hard vacuum stuff, they're testing into micro torr. We're at 5 torr, which is still pretty good.
You just explained something that I've always wondered how that worked. I'm just how do you do that? It's a basic question, but that's been something that people ask me, and I'm going, that's something you just explained it. Thank you. I've been wondering that for a while. I think it's very basic.
To me, it's really cool, and there's not a lot of people that do it. White Sands does it, but they use steam generation, and so their system, it can run for longer, but they can't turn it off. Right, so you start a chemical steam, and that system is the same thing, right? Except for the motive gas is steam, and then they can get a benefit out of the momentum by taking the water out. So they push steam through at high speed, and then they have a condenser that then recovers the mass of the water and then can help speed that flow up. We don't use chemical steam here for a few reasons. One of them is it's really difficult to power it. It takes a large amount of power to heat water. But then also you can't turn it off. Ours is a nitrogen system that has a gas blocker and a bunch of other kind of valving. So we can turn it on and do a 5 millisecond pulse and then turn it off. So we have a startup period of 10 seconds, do a pulse, then let it shut down. And so it's 20 seconds total. And there's a 5 millisecond pulse in there. With a steam generation system, you just turn it on and then you route the motive gas over the thruster. And when the thruster test is done, you route it away from the thruster, but you're still generating motive gas. And so it's $200, $300 a second that they'd be generating. With a nitrogen system, we can just turn it off. It's still pretty expensive, but we can just turn it off. Maybe a test fails and we need to stop it, or we need to reevaluate and stop it. But yeah, the motive gas system, you can turn them on and off and kind of flow through it. But we are capable of pushing, one stand right now is pushing 25 pounds of nitrogen a second. The other one is doing about 40 pounds a second, but it can do up to 100 pounds a second.
Is that the newer test stand? I was going to say, it's got to be the newer
one. Test stand, Animus, yeah. So Animus is, we just commissioned that in March. It's wild, right? So Agile built it. It was an atmospheric test stand, which means it just had a thruster sticking out the back of a Connex, and we just fired it outside.
And it always looks cool.
It looks great, right?
Always great.
Atmospheric testing looks the best.
It does.
But atmospheric also has a lot of issues with it. But we took that atmospheric stand in May of last year, moved it over to a new site, and then built a whole altitude system and finished it by March. It's a huge stand. It's got a 100 foot by 110 foot concrete pad. We've got 2 tube trailers parked on it that are 146 standard cubic feet of gas, and then a big ground storage tank, big 11,000 gallon nitrogen storage. And then that blows through, right? And it's got 2 containers, shipping containers, laying one direction, and then on top of that, orthogonal to those 2, is the top container. And that's where the cell is. And that at height allows us to have that altitude system. And that's got the fuel storage is there, the motive gas, the nitrogen is there, and the propellant storage is all there on that one site. But yeah, that's the newest one. And it can do instrumentation channels up to 1 megahertz. Primarily what we do is like a couple hundred kilohertz, but we can do down to 1 megahertz, or up to 1 megahertz, I guess.
I mean, who you all are testing for, the kind of testing you're doing, and also the kind of applications, it's got to be pretty wild, cutting edge stuff, given what you all can do.
Yeah, exactly. So we've got all the additive stuff in house here, so we can make our own, we can make other people's thrusters, slap them together depending on how quick they need to be. If it's a really rigorous program or like a dev campaign, I mean, we did 1 clean sheet design, 2 test stand in like 6 to 8 weeks, I think. So clean sheet thruster design, we built it, we fabbed it, we got it on the test stand, we hot fired it, and that was for a client that I think had some extra money towards the end of Q4, and they just needed to get through it. And so they turned us on in like November, and we hot fired before Christmas.
Wow. So the company name is really apt, is what it sounds like.
Yeah, Agile for sure. Agile for sure. Yeah, we ripped through stuff pretty quick. Like I said, right now we've got 4 thrusters that we're trying to test on the 2 stands right now. And the test team's there's only 7 of us. There's 7 people out there, and you get to have a lot of fun.
A lot of your reflections have been really cool about sort of the nature of test. And I feel like that's so valuable also for people who are, either making a lateral move into that world or thinking about it themselves, or maybe just people who are in it already. And I don't know if you have like words you want to share with them or people, or I don't know. I
mean, something that I say around here a lot is like test you must all the time. Like you can't do anything without testing, no matter how much you get into it, analytically. If you throw the best CFD at it, you do the best, kind of sample work or even prototype testing, like until you actually try it, you never know. Like until you actually take an empirical measurement, everything is not for sure. And I've seen that at big primes like Boeing, I've seen it at Raytheon, and I've seen it here. Like, I don't know how many times I've had someone come to me and say like, oh, this is going to work. It's going to be fine. Here are all the reasons why it works. Here are all the peers that it's been reviewed by. Here's, somebody with a PhD who says, yep, you're totally gravy. No problem. And then you go and you put it through its paces and it blows up. Or it doesn't blow up, but something weird happens. And, say we have a regen channel and it doesn't work and it burns. And they were like, oh, I didn't know about that one thing. So generally the advice I ever give to any engineer is always plan to test it. Test. And right now, space is really moving towards a very risk-tolerant approach. Get more into space. And there's some of that like test in space mentality, which I'd love to do. Like I'd love to build a test stand on the moon, and then I can really test in a vacuum. But the clients and everybody needs to know that they've got to plan on testing. And one thing I kind of teach all of our junior engineers, or even just people that are new to it, is plan on a few design cycles. And plan on having to go through and have learnings. You're going to find something you didn't know before, and you don't know what it is, but you can still plan to learn something you didn't know. And then your schedules become a little bit more realistic, and you don't have like the morale slam when you all of a sudden you're like way behind schedule. That's generally, I've got to test, and you got to plan for learning.
We'll be sharing my full conversation with Jaydee on Saturday's Deep Space episode, by the way, so stay tuned for that one. And we'll be right back.
Attention all security professionals. Want real-time IP intelligence at your fingertips? Sign up for Scout Insight's free trial today. Get immediate insights into threats, search any IP with no training required, and enjoy intuitive graphical results. Whether you need to identify compromised hosts or enrich Splunk queries, Scout Insight has you covered. Don't wait. Accelerate your threat response now. Visit teamcumry.com/cyberwire to start your free trial.
Welcome back. It is no secret that we are big fans of the James Webb Space Telescope on this program. I mean, you don't have to be a space geek like me to get excited about the images captured by this amazing instrument. Take the latest picture that looks like a diamond ring hovering in space. No, the universe is not asking us to go steady. The image is actually of a distant quasar, and you would be forgiven if you don't know what a quasar is. It is an extremely luminous active galactic nucleus. An active galactic nucleus is powered by a supermassive black hole with a mass ranging from millions to tens of billions of solar masses, surrounded by a gaseous accretion disk. Wrap your brain around that one. In this instance, the ring-like halo has been generated by a monster black hole at the heart of a young galaxy that shoots out powerful energy jets as it gobbles up enormous amounts of matter. This quasar, previously known to scientists, is named RX J131-1231. Why can't they not give it a simpler name? And it is located about 6 billion light years from Earth in the constellation Crater. The quasar's circular shape is the result of a phenomenon known as gravitational lensing, in which the light from a distant object, such as a galaxy, quasar, or supernova, as it travels through space-time, it gets curved by the gravity of another massive object located between the distant object and the observer. As a result, light appears to bend around the middle object, even though it is traveling in a straight line. The image is, of course, stunning. So, for an audio-only podcast, we really hate that you cannot see the image right now that I'm describing to you. So please, when you have a moment, go and check out the link in our show notes and tell us what you think. That's it for T-Minus for July 11th, 2024. Brought to you by N2K Cyberwire. For additional resources from today's report, check out our show notes at space.n2k.com. We're privileged that N2K and podcasts like T-Minus are part of the daily routine of many of the most influential leaders and operators in the public and private sector, from the Fortune 500 to many of the world's preeminent intelligence and law enforcement agencies. This episode was produced by Alice Carruth. Our associate producer is Liz Stokes. We are mixed by Elliot Peltzman and Trey Hester, with original music by Elliot Peltzman. Our executive producer is Jennifer Iben. Our executive editor is Brandon Karpf. Simone Petrella is our president. Peter Kilpie is our publisher. And I'm your host, Maria Varmazes. Thanks for listening. We will see you tomorrow.